actually works, more than most people who just install a cluster somewhere and run kubectl would need to have. Because let's be honest, you don't actually need to know what's happening in the backend if you're deploying something on top of Kubernetes. But we're interested in that. So let's take a step back and look what happens if we run a kubectl command to create a deployment on our Kubernetes cluster. What happens is we create a deployment resource inside our API server. I simplified this a little bit. So technically you'd have an etcd as a data store behind your API server, and there would be querying back and forth. So you wouldn't actually have it inside the API server, but for our purposes, this is good enough. So we have the API server, we have the controller manager and the scheduler. We have those as parts of our control plane running usually as pods inside your cluster. And once we create this deployment, the API server sends out an event. Our deployment controller runs as part of the controller manager, and that gets the event. And once it gets that event, it realizes, I need to do something. And it creates a replica set resource. So I keep saying resource because they're basically just lines in a data store somewhere that there is something existing. The same thing then happens with the replica set. The replica set is created, the control plane or the API server sends out an event, and then the replica set controller also creates a new resource inside the API server, so the pods. At this point, we don't actually have any containers running from our deployment, so there's not really anything happened yet except a few resources being created in our backend. Having the pods kicks off the scheduler, and the scheduler then assigns your pod a node that goes by whatever algorithm you have running inside your scheduler. So it doesn't have to be the Kubernetes one. You can also write your custom schedulers, but that's a whole other minefield. And once your pods have a node assignment, have decided where they should actually run, the event going out from the API server is listened on or gets talked to by the kubelet. Sorry, my doorbell is ringing, so I'm just ignoring that, but okay. The kubelet gets that event, and as soon as it gets that event, it actually creates our container on the node. So this is the point where we actually have a pod running, where actually something happens in our cluster. That was the data flow on what happens. The two controllers that we've seen so far, the deployment controller and the replica set controller, have two very specific purposes. So they get the current state and the desired state from the API server. The desired state is specified in what you see in YAML files as the spec. So you have, for example, for deployment, a definition of how many, or what image would I use, or how many replicas. And then there's the current state. And the current state when we create a deployment resource is basically nothing, because there is no underlying resource. It sees that, so the controller sees that, and then adjusts the current state to match our desired state. This is done both when it is triggered by events, but it is also done in regular intervals. So this is why your pods come back up if you delete them, because your controller sees, there should be a pod running, and there isn't. And then your controller updates that. The entire concept is called a control loop in Kubernetes. It's pretty much a pattern that's repeated all over the place. And I mentioned extending the API before. So we do have built-in controllers, as we saw the deployment and the replica set controller. There's a few more running in the controller manager, but those are only for the Kubernetes kinds that we are aware of. So they're only for deployments, for pods, for replica sets, and so on. They're not actually for whatever random application you might want to run. But what if we want to use some random application with some random specifications that need a resource that is actually aware of something specific to our application? while still keeping the Kubernetes features like validating our resources or validating our custom fields, using defaults that can be set by that, or versioning. So all of these things you can still keep from the Kubernetes API, but extend with your own version by using custom resources. Custom resources and custom resource definitions, you can see here. So on the left side, we have the custom resource definition, and on the right side, we have a custom resource. Think of a custom resource definition as a blueprint. So if our Kubernetes cluster wouldn't know what a deployment is, we would have to tell it what is a deployment, how do we define it. So the custom resource definition is basically the definition of what kind of resource you can create. In our case, we're defining a custom resource for a Tomcat, and on the right side, sorry, we're defining the custom resource definition, and then on the right side, we have the custom resource. Let's look at the specifics of that. In our specs, we need a group and a list of names. Those are used for later on when you actually query the Kube API to see your custom resources. So if you want to see, do I have deployments, you do kubectl get deployments. If you want to see, do I have custom resource Tomcat, I would say kubectl get Tomcat. This is all defined here. You do this for singular, plural, kind, and short names, so you can actually have various versions of querying, also because they're used in different variants. Grouping allows you to actually put different custom resources into, I want to say not clusters, but actually into groups, yeah. The same thing is actually happening with most Kubernetes resources. They also fall into different groups. For our schema, we can define the type, the format, and a few other properties using the Open API specifications. So basically, you get a version that allows you to validate certain fields of your custom resource. In our case, we're defining 3 properties. We're defining a var, so a web application archive for our Java, for a Tomcat, then a version for a Tomcat, and the amount of replicas. And we're defining what kind of types we want. This is a very simple version, so you can make this a lot more complex, but for our purposes, this is fine. And you can see the fields on the right side. And if we were to put something here that wouldn't match, the custom resource definition would ensure that the API server throws an error when we try to, for example, say version A. And the last part, you can version your custom resource definition endpoints. So what you get with the custom resource definition is basically an API endpoint. You can version that one, so you can use different versions at the same time that are also active at the same time. And the scope part at the end is basically just that you have a Tomcat per namespace. Since you can see on the right side, we're not actually defining a namespace, it just gets dumped into the default namespace, as with all resources in Kubernetes that don't have a specific namespace. You can also have cluster-wide custom resource definitions that don't get put into namespaces. The difference is not that big. It's more of an how do you access what kind of thing. Okay, that was it for custom resources. And now we take a look at custom controllers. For writing a custom controller, you have different options. The most commonly used SDK, I would say, is the Operator SDK on the top left. This is the default framework in Go. So whenever you have used Go before, or if you have used Go before, if you're comfortable with that, I would say go for that one. There's also Kudo, Kubernetes Universal Declarative Operator, which allows you to write operators in mostly YAML. I haven't tried it before. I hear it's interesting. If anyone tries it, let me know, tweet at me or send me a message or something, because I'd be curious how it actually goes. Then the java-operator SDK, I guess from the title of the talk, you can guess which one we're using. And then for the from scratch people, you do have the APIs for Kubernetes. So there's both API client libraries for Go, Java, Python, JavaScript, Haskell, community libraries for Clojure, Lisp, Node, Perl, PHP, Ruby, Rust, Scala, and so on. And I think in the time that I've told you all of those, I've probably written 3 more. So those are available if you want to write your own operator from absolute scratch without actually having any kind of thing in between. Wouldn't recommend it, but there are those people. Okay, some people might be asking themselves, why Java? I'm gonna go with why not? Java has a huge community. There's about 7.2 million active GitHub repos versus Go's 650,000. So almost more than 10 times as much. Java is making good work in moving into the more cloud native space with, for example, Graal VM, which does help you with microservices and a smaller footprint, especially for memory and for time starting up and everything. Same with Quarkus. So they do help you if you want to write Java in a way that is not too resource intensive. And now if we look at the java-operator-sdk, if we do want to get started writing our own operator, we need a few things. We need kubectl configured locally. So whenever you use a cluster remotely or locally, have kubectl pointing at that one. We already got a question. So you have a few different options, Minikube or Docker, that's Kubernetes for Mac is, I think, Docker desktop, I think that's right. Yes, that one also allows you to have a Kubernetes cluster locally. A few cloud services. I think you can get started with minimal nodes, so you don't actually have to pay for it. That's something you might want to try out. First step. And then once you've done that, you write your custom resource definition for your application and your custom resource for your application. This is assuming you actually have an application that you want to write something for. If you don't, do the same thing I did. Take some Docker image that already exists, like a Tomcat or an Nginx or some generic image, and just try it out. Next thing we do is we add a Maven dependency for the Java operator SDK to our Java project. And then there's quite a few examples on their GitHub repo. I have the link at the end. Take a look at those to see what kind of resources you need, and then we can actually get started writing a controller. An operator is not necessarily just one controller, but usually you have at least one controller, so it actually does something. And the parts you need in our case are 2 methods, the create or update method and the delete method. Take a look at those. The first part, you can see we have a Tomcat class, which just looks at our Tomcat CRD and sees what kind of fields do we have. And we define the CRD here. The second part is then the create or update resource method. And this is where you actually write your Java code. This is where you put the code that you want executed when this controller / operator gets an event from the Kubernetes API that our custom resource has been created or changed. We'll take a look in a second how the code that I wrote looks, but this is basically anything. So you can have cloud resources created. You can have logic for changing something in a database. It could be pretty much anything that you want. And then the delete resource, anything that you want to happen when the custom resource is deleted. So usually it's a cleaning up kind of thing, or making sure that you're actually supposed to delete this and so on, whatever you want to happen. Okay, then after we've written the controller, we have to package our controller into the operator and then deploy it as a Kubernetes deployment on our cluster. For testing purposes, that's why kubectl configured is good. You can do it locally, but once you have your operator in a Kubernetes deployment, you can have it running on your cluster longer term without having your IDE connected all the time. So this is just the entire idea, to have your operator running as a Kubernetes deployment to manage your application running Then let's take a look what actually happens when we try this out. Let me make this a little bit bigger. Citation mode. Yeah. So this is the controller that we just saw on the slide, except it has a little bit more code in our creator update resource method. In our case, creator update deployment and creator update service. So we're doing a very simple thing. When somebody creates a custom resource, we want to create a Kubernetes deployment and we want to create a Kubernetes service. You can see here we're using the Tomcat version from our CRD, from our custom resource, and the var from our custom resource and replicas from our custom resource, and putting them into the actual deployment. And then for the delete resource, we're doing the cleanup afterwards. We're just getting rid of the deployment and the service again. Okay. Let's start a watch to see that we're actually creating something. Just looking at the pods, the services, and the Tomcat. Getting an error here because there isn't actually a Tomcat CRD yet, so it doesn't know what a Tomcat resource is. We can actually take a look at our cluster and see, yep, no Tomcat, but we do have a few other pods running, basically just the system pods. Once we apply our CRD, or custom resource definition for our Tomcat, we can see now it is aware of a Tomcat, and the currently existing service is a Kubernetes service. We just ignore that one. That's a default one that exists. So look at the CRDs. And if we take a look at this, this is the CRD we just saw on the slides, where we're defining what our Tomcat custom resource is supposed to look like. Next thing we do, we apply the custom resource Tomcat. And we see we have a custom resource showing up. And if we go out and check here, yes, we have a custom resource called Tomcat. And if we look at that one, we see it's the one that we also saw on the slide. Nothing else happened yet. And you know why? Because we don't actually have an operator yet running yet. So this is basically what happens when you use a custom resource without any kind of controller, using or watching it and doing anything, nothing. So let's delete that Tomcat again. And goes away again, that's good. What we want to do now is package our operator. I'm currently in the home directory of my Java project. So what you can do is add a Docker file to Maven that allows your Maven with a plugin to build your Java project into a jar and then add that jar to a Docker file and then run that as a container, including the deployment. But let's build our project first and build the Docker image. It's going to take a few seconds, but we can see, so we have a demo, we have a version 1.0 snapshot. And once that is done building, we can check if the Docker image is actually being created locally. Usually you'd put that somewhere on, probably not Docker Hub anymore as they changed their image policies, but somewhere remotely. And pull it from there, but in my case, I'm just having it locally and pulling it from my local image store. You can see here, this is the Docker file steps that we're walking through. So the add jar file and then actually running it at the end. Let's see. Yep, so we built our image a few seconds ago and it's the right one. So what we do now is we apply the deployment YAML. And in our deployment YAML, you can see there's a few more resources than just the deployment. So we have a namespace first. You can see, yep, namespace got created. We have a service account. which is the default service account that our Tomcat operator deployment is using. We have the deployment itself, which is using the image that we just built. A few other things, and the most important part, or second most important part after the actual operator, is the cluster role binding, because you do need your operator to be allowed to talk to the Kubernetes API and create and delete resources. So you're binding the cluster admin cluster role to your service account, so that your operator is actually allowed to do whatever you would be allowed to do if you're cluster admin, which most people are when they create their own cluster. Okay, so we created all of this. Let's take a look if our pod's happy. Yep, it's running. Logs look good, no errors. So let's try the applying again of our Tomcat resource. Okay, created the custom resource again, and yay, something happens. So now we actually have 2 pods showing up, and we have a service. Service is running on pod 30,000. So as soon as our pods are up, let's check if we actually have something running. Let's hope so. Yay, something is there. Now that we've done that, we decide we don't like the sample application. We think it's stupid and we'd like to use our own. So we take a look at our Tomcat and we change our var file. I hope I got this right. Let's see. Once we change something in our custom resource, our operator gets the information that an event, or gets the event that something has changed and changes it. In our case, it changes the deployment, and we see new pods are starting up and the old ones are terminating. This is actually done as a rolling upgrade, as in we create a new pod and only then the old pod is destroyed, which is actually a Kubernetes deployment feature that you get. So this is not something I wrote. This is just happy usage of the Kubernetes functionalities. And okay, those are running. So let's see if we have our new version. Oops, I refreshed Zoom and not the right page. Oh, that's okay. And we have a random sample app. This is where my web developer career ended, so there we go. But we're happy with this one. We're thinking this is good enough. So let's see, we have an Apache Tomcat 9 running at the moment. We think this is not a good thing to have, so we go for changing the version as well. So let's go for 10. And the same thing happens again. We see new pods starting up, and once that's running, the other ones are going down again. And same thing with the second pod. Service isn't actually changed because we didn't change anything in our custom resource that impacted the service. We could add, for example, the node port as part of the custom resource so that it's changed as well, but not really necessary in our case. But let's first see if our Tomcat was upgraded. Yep, so now we're actually running on an Apache Tomcat 10. And once we've done that, we're done with our demo. So we just delete our custom resource again. And by deleting the custom resource, we get rid of everything that we just created, because you don't actually have to clean up after yourself. The operator does that for you. And they're terminating. I think that's good enough for us. So let's get back to the presentation. Okay. These are my backup slides, so don't need those. Yay. Here we see what just happened in the same workflow image that we had before, except we added the operator and we added the custom resource definition. We do need the custom resource definition so our API server actually knows what we're talking about, because otherwise it'd just be confused if you tell it, create me a Tomcat. So once we create our custom resource, the event goes to the operator and the operator creates our resources. And as I said, you don't actually need to do something inside your cluster. You could be creating EC2 instances or something in a bucket or changing something about existing instances. It doesn't have to be this workflow. But the nice part about creating Kubernetes resources is that everything else inside the Kubernetes ecosystem still works. So the same workflow at the end as in creating pods and actual containers for you. It's not something I did. This is something that happens because it's Kubernetes. And the only thing I did was basically allow it to do kubectl deployment upfront automatically. You might be thinking now, this is basically just a Helm chart. So I can run a Helm chart and have a service and a deployment created. And you wouldn't be wrong. You would get the same thing, except you wouldn't get it automatically. And the creation and the installation and the config management is just the first step of what an operator actually does for you. This is the operator framework's maturity scale. So it's not actually how you're supposed to follow the line of making the perfect operator, but it is a way of grading the existing ones. But I like it as an alternative to listing 7,000 use cases, because this kind of gives you an idea of what it can do for you. So starting from the basic installation, after that you get usually minor upgrades and patch upgrades as the seamless upgrades. And then you move on to full lifecycle management. So application management and storage management. The storage management is a really big part because most operators go for stateful applications. So you do have some sort of data management going on, from backups to reinstating something, or if you upgrade your application, you don't have to worry about losing something, and you don't have to know how to manage the storage. One of the first operators for Kubernetes was the etcd operator, so managing the data store behind Kubernetes. You don't have to know how to add a new etcd node. You don't have to know how to manage a quorum. You don't have to do all of those things because the operator does it for you. Assuming somebody who knows about it wrote it, but that's just minor things. The next thing you would get are the deep insights. So going to any kind of monitoring, to logging, to getting workload information, and having that information allows you then to move on to the last step, which is the full autopilot, which also includes then minor error fixing and running the whole application for you without you having to do much. The autopilot is also sometimes described as you having a tiny software SRE running inside your cluster, which I personally love. So it's a great thing to describe an operator, that you have a tiny SRE in your cluster that knows everything about your application and takes care of it for you. And that's it for the levels. If you're interested in reading a bit more, there is a great blog introducing operators. It's a little bit older, but it's the intro from the actual people who started it. There's the Kubernetes documentation, and there is a book called Kubernetes Operators, which is also where the software SRE statement comes from. It's mostly on the Go operators, but it is a nice intro in the background of it all and how to get started. You don't have to write operators for every kind of database that you meet. If you feel like it, go ahead, but there are quite a lot of operators out there already. So there's this list on GitHub, and there's a list on Operator Hub that gives you anything from most monitoring tools to most data storages to also a few other Kubernetes applications, and also lots of web servers and everything. Like Tomcat, for example, does actually have a functioning proper operator out there. So my version of it wouldn't make it, but you know, it's there. And the frameworks and SDKs we already talked about. Okay, thank you very much for listening. Does anybody have any questions? Feel free to also use the chat or Sam.
Thank you, Charlotte. Indeed, like I've encouraged people to ask questions in the chat. You had like a good comment about your console, so I'm not the only one to like it. The console setup is very popular.
Okay, nice.
Please, everyone, feel free to unmute yourselves if you have a question for Charlotte.
Good question. Celine, what was a use case for creating an operator? So we had a customer not my customer to be honest, but a customer from a colleague who was looking to create Jenkinses, I guess, automatically. So they had an operator that gave it a CRD, and then by giving a custom resource, they were creating a Jenkins machine outside of Kubernetes. So for them, they were setting up CI/CD pipelines for every single team, and every single team got their own Jenkins. So that was the actual use case that we had with the java-operator-sdk.
I hope it answers your question, Celine. Yes, apparently it did. All right, so unless anyone else have other questions?
I have a question here because I was attending a little bit in parallel to this Rancher meetup about K3S. So what kind of solutions are you using? Because I saw Charlotte was using Minikube. So what do you think? What do you do for your local development or your local Kubernetes experience? What are you using? Because I am curious, like they are I see new software and new things that they're coming. So
mine's actually Docker desktop for Mac, but to be honest, I don't use it all that much. Usually it's the client's development environment. So my local version is just for showing things when I want to make sure I don't need an internet connection. Usually we have a development cluster up somewhere that is being used to mimic the real environment properly.
By the way, Charlotte, you mentioned that you are using EKS on AWS. Any thoughts about EKS in particular in comparison to like bare Kubernetes clusters or any other cloud providers?
So EKS comes with its own issues for especially upgrades. So they still want you to like update your own kube proxy and everything. I think they changed that now with managed nodes, but it's still less than ideal. So GCP is a lot nicer from that aspect, but I mean, it makes sense, right? Because they kind of pioneered the whole thing. But I think it makes sense for people who don't have too much Kubernetes experience and don't want to be the ones responsible for keeping their control plane up and running. So yeah, it did limit us last time because we were looking for certain, we had a client that had very specific security requirements for credit card payments. So the whole PCI compliance thing, I just don't even want to think about it anymore. It's a specific kind of network policies without in pod security policies that don't do what you want them to do, and RBAC rules that hurt, but you learn a lot the hard way. So I think for that, having very specific requirements, having your own host cluster on, I don't know, maybe EC2 or something is easier. But it always depends on your trade-off between how much knowledge you have, how much time you want to invest, and how much you're actually expecting from the cloud provider.
Thank you very much, Charlotte. It was really a pleasure to have you talk at Software Circus, and I hope you do it again.